this is what a problem would look like. All right. So what we have here is a phase diagram, which, if you remember, was from slide 4. So this slide right here. And what we're going to do is we're going to answer these questions about this phase diagram that they gave you right up here. All right. I'm going to help you with a couple of them, and then I'm going to give you a few minutes to try them on your own. All right. So let's just go. I'll pick a couple random ones just so you get an idea of what it all is. So first up, it says, what phase of xenon? All right. So I guess this is xenon, right? So what phase of xenon are present for temperature pressure readings in each of the following regions of the phase diagram? So it says directly above line AB. So if we look at this, here's A and B, and then directly above it, all right, this is pretty easy, right? It's just solid. So that's good. Fill that in. All right, so we did one that's above. Below, you would obviously just kind of check and see what's below. But what about on them? So if it's on curve BC, so that's B and C, and we're looking for the phases, right? So it says, what phases of xenon? So if it's on the line, you would have to say both. So if it's B and C, which I think is what we're talking about right here, right? B and C, it would be both whatever's to the left and the right of it. So it would be solid and liquid. So we would say solid and liquid. Okay. And then that's pretty much all of those. All right, so that's number 1. So you guys are going to fill in the others in a sec. And then number 2, it says, given a sample of xenon at any point on curve BD, what effect would each of the following changes have on the sample? All right, we'll do all of 2 because one will be a pressure and one will be a temperature question. So it says increasing pressure while holding temperature constant. So we're just going to change the pressure. So we're going to increase pressure, which is this axis over here, all right, the y-axis. And we're on BD. So BD is this one. All right, so if we're on this line right here and we increase the pressure, it means it's going to go up. It's going to turn into a liquid, right? So what effect would each of the following have? So if it's a vapor and it's turning into a liquid, what was the term for that when we went from vapor to liquid? So we would say it would condense, and then we would say vapor to liquid so that we know what we're talking about. If I could type, that'd be great. All right, and then let's try the same thing. So now we're on BD, and it says increasing temperature while now we're holding the pressure constant. So temperature is the x-axis, and we're still on BD, right? So now if we increase the temperature, we're going to be going this way. So we're going to be going from liquid to vapor. All right, so we're going to be going liquid to vapor, so that would be vaporization or vaporize. And this would be liquid to vapor. All right. Same thing's happening with these now. Instead of increasing, we're decreasing. And then it says number 4, given a sample of xenon at any point on curve BC, how could more liquid xenon in the sample be made to solidify without changing the temperature? Okay, so if you can't change the temperature, you're going to change the pressure, right? But it's asking you to make more liquid. So is it going to increase or decrease the pressure? So you guys think about that one too. We'll come back to it. And then it says, given the value for each of the following for xenon. All right, so what's the triple point temperature, the normal melt? All right, so you guys can use the chart above to figure all that out. All right, so here's what we're going to do. I'm going to give you guys a few minutes to go through this slide on your version. All right, fill it in, and then we're going to go over it. All right, so on line AB. So whenever it's on a line, that means it's going to be 2 different phases. So if it's on line AB, since solid is above and vapor is below, or to the right, you could say, it's going to be both solid and vapor. BD, same thing. It's going to be both. And BD is liquid and vapor. And then directly below AB, it's going to be vapor. And then B is the triple point, so it's going to be all three. It's going to be solid, liquid, and vapor. All right, and it's good to know the word triple point. Well, it doesn't specifically ask you for that, but it is good to know. All right, we did number 2. So let's jump to 3. And it says, given a sample of xenon at any point on AB, what effect would each of the following changes have on the sample? So let's decrease the pressure on AB. So AB is here, pressure going down. It is going to form more vapor, right? All right, so it's going to form more vapor, but it's going from a solid to a vapor. So we would say that it's subliming, all right? And that would be solid to vapor. And let's check out the other one. And decreasing the temperature. All right, so temperature going down. I'm going to start here. Temperature going down is going to go to the left. So that's going to make more solid. So that's going to be deposition. And that is vapor to solid. All right. And then the last, or number 4, we have given a sample at any point on BC, how could more liquid xenon in the sample be made to solidify without changing the temperature? So we have to change the pressure, and we want to make more solidify. So BC, more solidify. BC, more solidify. We can only change the pressure, right? So if we increase the pressure, more would solidify, right? Because if pressure goes up, we'll be in the solid region. So pressure going up would be our answer for that one. Increase the pressure. All right, given the value for each of the following for xenon, all right, triple point temperature. All right, triple point temperature, it's around negative 121 degrees Celsius. The triple point pressure looks like 37.5 kPa. The normal melting point is negative 112 degrees Celsius. And then the normal boiling point is negative 108 degrees Celsius.